Okay, so today we want to look at how to determine the speed of sound in air. So we are using two methods. The first one is echo method and the other one is direct method. Direct method. So now let's begin with the direct method. Direct method is a simple method. For example, you have one person standing here and the other person standing here. Let's say, for example, the distance between them is 100 meters. So now this person holds a gun, then this one stopwatch. So now when this one fires a gun, when you fire a gun, the first thing you see is light, then the sound will be heard second. So the duty of this one is to record the time between seeing the light and hearing the sound. So when he measures that time, then we are going to use the formula speed is equal to distance over time. So that is the first experiment that has to be done. Direct method. Then the second method is echo method. Now, for example, you see this in the video. This one is clapping, and then this one is having a stopwatch. This is a wall, a tall building. So now what happens is this person has to clap. Okay? Then immediately he hears the echo, he claps. Immediately hearing the echo, he claps. So the duty of this one is to record the time after 50 claps. Now remember that these people are standing at a certain distance from the wall. They are the same distance. So now what we mean by echo is that when the sound reaches the building there, what happens is it comes back. So here, the formula that we are going to use is speed is equal to 2 distance over time. So that's the understanding there about the echo method. So that method is called echo method. Two methods can be used to find the speed of air. Now let's talk about quality of sound or characteristics of sound in short. So on characteristics of sound, we'll talk about one, the pitch of sound. So pitch of sound depends on frequency. Remember, when you see a waveform like this, it means here the frequency is higher, but here it's lower. So meaning that here the pitch is higher because the frequency is higher, but here the pitch is low. So properties of sound, one, pitch of sound. The greater the frequency, the greater the pitch of sound. Number two, we are talking about loudness of sound. Loudness depends on amplitude. So this one, it is higher amplitude because it's close to each other, the wavelength. But here the wavelength is bigger, so it means the amplitude is lower. So because here the amplitude is bigger, so the sound is louder. Here the amplitude is lower, so the sound is lower. That's what it means. So this is louder, this is low loudness. Then the last one is quality of sound. Now when we talk about quality of sound, we mean different frequencies being put together. They produce a quality of sound. But you realize that the quality of sound in a small speaker, the same sound if played in a large speaker can sound differently because there, the frequency that will be there will be different. So that's what we mean by saying quality of sound. So basically, these are the characteristics of sound. One, quality of sound. Two, loudness of sound. Remember that loudness depends on amplitude. Then the other one is pitch, which depends on frequency. Thank you for watching.